Hello and a very warm welcome on behalf of NTI Audio. We are ready to start today's presentation. When operating an audiolizer like the FX100, you frequently are challenged by interfacing it to external devices. You have to embed the system into a application, into a setup that may, for instance, comprise a foot switch to trigger the test or a stack light for providing a visual feedback to the operator. Maybe you have more sophisticated devices connected to your test setup, like a barcode scanner or even a barcode label printer. Or maybe the whole system is controlled by an external controller, symbolized here by this programmable logic controller PLC. And the topic of today's webinar is how to establish these connections, how to integrate the Flexus audio analyzer in such an environment, how to establish all these connections and interfaces. My name is Markus Becker and I'm assisted today by Greg Schmiedle, our product manager, who is responsible for the Flexus line. Within the next half an hour approximately, we will present you the basic system configurations of the Flexus audio analyzer. We have prepared two major practical presentations. This part actually is the major part of today's webinar. Then we will summarize what we have shown to you and also provide some hints and tips on the hardware interfacing. At the end, we will at latest answer your questions and also add some additional information. So let us first take a look at the typical system settings of the Flexus audio analyzer. And we start here with a first typical setup, and we call it the standalone application, where the controller PC is the master of the system. So that means that there is no external controller, no host controller, no external PLC that would drive the system. It's just the PC that is connected to the FX100 via the USB link. And this PC is the master of the system itself. In this case, how can we connect these peripheral devices to the system? There are actually two different ways. The first one would be to connect them directly to the controller PC. For instance, a barcode scanner is usually connected via USB, same as the printers, whereas a foot switch or a stack light are typically connected to a digital I/O card. And this digital I/O card, of course, needs to be installed in the controller PC. Alternatively, you could also use the built-in auxiliary I/O interface of the FX100. And this digital interface offers 8 input channels and 8 digital output channels. So you can connect, for instance, the foot switch or the stack light directly to this auxiliary I/O interface. And the advantage of doing so is that you do not need to install a digital I/O board on your PC. You have a simplified programming of the test sequence, and you have a very direct and short connection between these two devices and the interface. The second basic system setup would again comprise the controller PC that is controlling the FX100 via USB, but now the master is an external controller, for instance a PLC or any other type of controlling computer. The communication between this master and the controller PC would be typically via TCP/IP, Ethernet, or could also be a digital I/O interface or any other kind of communication channel. So how can we connect the external devices to these system components in this case? Actually, there are 3 different modes. The first one would be to connect these devices, as you see here on the left-hand side, connect these devices to the master, to the controlling master. And second alternative would be to connect them to the controller PC, for instance, visualized here by these two printers. And the third option you have is similar to the one before, connect them directly to the auxiliary I/O interface of the FX100. And this applies not only for the very simple devices like foot switch or stack light, you may even connect a PLC to this auxiliary I/O interface and simplify your whole setup in this way. So let's come to our practical presentation part. I have here on my desk a demo setup with an FX100 and a very simple acoustical test setup. You can see it here. I have a small active loudspeaker and a measuring microphone and some peripheral devices, actually a foot switch, a stack light and a barcode reader. And I want to show you how to interface to these external devices first by using the RT speaker software and in addition an emulation software of a PLC. Unfortunately, I cannot show you the PLC programming in this presentation, but I have here a software package that emulates such a PLC and that actually acts as a remote control of the RT speaker software. And the second part of my presentation is where I'm symbolizing the standalone operation. So here I'm using the FXControl software to show you how, in this case, the external devices would be embedded into this application. So let us swap over to this part and to the practical part, starting with the RT speaker application. First, we have to set up the configuration of RT speaker. And we start here in the serial number and barcode tab, and we enable this functionality. And this means that now the RT speaker is able to read a scanned barcode and to use it, for instance, in a log file, or also to use it as a trigger command to start the execution of a test. Then we go to the network settings, and here we have to activate this feature here, the launch TCP/IP remote control, and we have to enter a port number. Port is the communication channel of the TCP/IP link. And if you're insecure about the correct number to enter here, please ask your IT specialist. He will assist you to finding the correct number. We have chosen the 50,000 port for our presentation here. Next step, we go to the interface tab, and here we decide which items, which devices shall be enabled to trigger a test. So I can start a test by pressing the F1 key of the keyboard. I can start the test via the digital I/O interface by reading a serial number with the barcode scanner or through the TCP/IP link. I can make my own selection according to my demands. Then in addition, I have enabled here the feedback of the test outcome to an external device, for instance, a stack light. So this activating this radio button means that now the RT speaker will be enabled to feedback this information to an external device. In addition, I could even enable here the triggering of the calibration cycle via the digital I/O interface, or I could also enable selecting a specific project from an external device. I renounce on doing that for this presentation because it would just boost the range of my presentation. I want to focus on the more simple and the more basic features and the basic functionality of this interfacing. Very important, please don't forget here to select the digital interface you want to use in your setup. As said before, the Flexus Digital I/O is a standard feature of the instrument. That's the reason why I choose it. If you would have a digital I/O board installed in your PC, it would show up here in this list and you could select it as an alternative. Now coming back here to the feedback mode, let's take a look at the pin assignment. Sorry, I have to delete that first. And I show you now how to use this feature. For instance, I want to indicate that the sequence is running, the system is in operation via the yellow light of my stack light. And this is connected, the yellow lamp is connected to output number 2. So I connect this feature, this information to output number 2 and add it to this table. Similar, I can also visualize the cycle result, the passed failed result. Positive would mean passed, and that would be connected to pin number 3, which is the green lamp. It's correct. And the opposite, cycle result negative, failed. A failed would be shown on output pin number 2, and that is the red light. So I save and quit my settings. And now the next step I do, I launch this emulation software that acts as a PLC. And the first action here I have to do, I have to establish the communication between the software and the RT speaker. And normally here I would enter the name of the PC, the controller PC on which RT speaker is running. In my case, it's the same local machine as the one on which this software is running, and for that reason I can just press enter. Otherwise, as said before, I needed to enter the identification of the PC. Next step, I have to enter the port number. You remember that was the 50,000. I confirm, and consequently this window opens the window of my PLC emulation software. So this is now in control of, this is controlling now the RT speaker software. So I select the launch project command and I enter the name of my project. You see here, this is a project that I have prepared that includes all the test parameters of my setup here on my desk, and I enter the name, press enter, and consequently the production mode starts. And in addition, this window here opens because I have activated it, the barcode scanner communication window opens as well. So to start a test, I have 3 options. I could enter manually via the keyboard the serial number and press enter. I could scan the barcode, but what I want to show you here, I use again the remote control software. I enter the serial number of my device via this software, and as soon as I press the enter button, it will start the execution of the test sequence, and you can watch that in the small video screen on your monitor. I guess you have seen that during the execution of the test, the yellow lamp was on, and then at the end, as the result is a pass, the green light is on as a positive feedback. Now let's do the same, but this time I'm gonna compromise the test so that the test is failed. I enter another serial number. And you can see here, due to my interaction, the outcome was failed. Consequently, the red light of the stack light is on. So this is what I wanted to show you, how to integrate these peripheral devices into the RT speaker environment and how to remote control the software from an external controller represented here by this PLC emulation program. So I stop it and swap over to the other application, the standalone mode, and for this purpose I need the FXControl software. The FXControl software comes along with every FX100 instrument. It's free of charge. It provides access to all features of the Flexus analyzer, and it also includes a very helpful feature that I'm going to show you now as well, the sequencer mode where you can establish test sequences according to your demands. Here it is. I'm just loading a prepared project, which is very similar to the one that you have seen before under RT Speaker. So I'm having a frequency response measurement, a distortion measurement here in the first step, and in a second step I have a pure sound rub and buzz test. Let's run the sequence. Maybe you have noticed that the second glide sweep had a higher level. I intentionally selected this higher level because this is a very typical application that in a speaker test you would apply a higher test level for rub and buzz detection rather than the standardized level for frequency response and distortion level. You also see the outcome, all the tests are passed and everything is fine. So let us take a look now how to integrate these external devices under FXControl. I open the sequencer mode, and the first thing I do, I enable here the auxiliary trigger, pin number 2, and that is actually my foot switch. So the foot switch that is here on my desk is connected to the input pin number 2 of the auxiliary I/O interface of the FX100. And as soon as I press this foot switch, the sequence will be started. The next action that I want to add is to reset the stack light. So I press the add button, and here you see there's a selection of actions that I can execute, and here I select the auxiliary output. Here I have the 8 output pins of my auxiliary I/O interface, and I activate pin number 2 that was connected to the yellow lamp, and on the other side I disable or I put the pins number 1 and 3, the red and the green light, to 0, which means off. So after this action the yellow light will be on, and I can give a name to this action and I call it reset stack light. And you see it up here, so this will be the first action to be executed. Then let's say we want to read the barcode of our device under test. And here I'm selecting the input action. I call it read the barcode. And I can even add an instruction to the operator, read the barcode of the device under test. Or better, scan. Okay. In our sequence, I would continue with state number 1, the frequency and distortion measurement, activate the second sheet with the rub and buzz test, and now I would like to display the outcome of these tests on my stack light. So again, I have to add here an auxiliary output action, and this time I switch off the yellow LED because my sequence is finished, but now I have to add a Boolean expression, the result, the passed failed result of our tests, to the 2 remaining lights. So the green one, I would click here until I see this Boolean status here, and now I have to assign the outcome of one of my measurements to this button or to this pin, and I'm selecting the overall passed failed. So if the overall passed failed is positive, then pin number 3 will be active, which means the green light will be lit. And in the opposite, I do the same for the red one, but now I select the failed status, and I will show you what stands behind this entry just in a minute. I confirm, and I save my sequence. So coming back to this overall passed failed and the failed status, these are calculation items which are provided by the software, and I can program them according to my demands. Here, for instance, you see the overall passed failed comprises the 3 measurements that I'm executing, and only if all 3 measurements are passed, if the recorded results are within these shaded areas, within the acceptance ranges, only in that case the outcome will be positive. And in case of the failed, I'm just inverting the outcome of the output passed failed, overall passed failed. So if that one would be negative, it's failed, then the inverted outcome would be positive, so the failed calculation item would be active and the red LED would go on. Let us take a look how this works. So this time I'm going to manually press the foot switch to initiate execution of the sequence. I need to read the barcode. The sequence is executed, the result is positive, and the green lamp is lit. Maybe you noticed, same as before, during the execution of the sequence, the orange lamp was lit. Now let's do the same as before. We compromise the test intentionally. I start the sequence and I scan the serial number. I have a failed result and the red LED is on. So you see, this way you have a wide range of opportunities to create your sequence according to your demands. You can select of output pins, the output pins for your auxiliary I/O, or the input pins if you want to have more input information. You have a wide number of features that are supported. For instance, you could program, you could call an executable through this action here to print a barcode label, and so on and so forth. We actually have already held a webinar on this feature on the sequencer, and you will find that on our website if you're interested in learning more about that. So let's get back to our presentation. And summarize what we have just shown to you. We had the two software packages, FXControl and RT-Speaker, and you have seen how to remote control RT-Speaker through a TCP/IP link, so how to remote control the system by a master PLC. Then we have also shown you the auxiliary I/O interface, how it can be used, for instance, to trigger a test. Talking about the test sequence itself, the FXControl offers you free definition of these test sequences with the features that are provided by the software, whereas RT-Speaker has a kind of a predefined execution of these tests. You have a certain freedom to add more actions to that sequence, maybe to execute two different projects, to test two different devices with different test parameters in a row, but the basic order, the basic execution is predefined, so your abilities to amend this sequence are restricted, whereas under FXControl you're absolutely free. Then both software packages allow to control this auxiliary interface of the Flexus analyzer. You have full access to all the I/O pins under FXControl, a little bit limited access under RT-Speaker, especially the input pins are not all of them accessible under RT-Speaker, but basically this function is supported. You can trigger the software by foot switch, or you can feedback the outcome of the test result to the stack light, and so on. Barcode functionality is also supported in both packages, both reading and printing barcodes. And last but not least, if you want to generate a test report, if you want to generate a printed sheet or a PDF of the outcome of your test, you can also do that in both software packages. Some words about the hardware interface. I have always spoken about this auxiliary I/O interface of the FX100, which is a connector. How can you connect that in reality to these devices? We are actually offering a new product here that will be launched in the next days, where you can interface the connector from the FX100 that is connected to this one here to these pins, input pins, 6 input pins and 8 output pins of this board. The board can be powered in different ways, either via USB, or you can connect it, for instance, to a PLC with these 2 pins, or here with a power adapter. So you can apply different voltages according to your demands, and then you can very easily connect your external devices to the corresponding input or output pins. We have here LEDs that indicate the status of the output pins that are controlled by FX100. And we also have a manual switch. That's a very helpful feature when you are in the process of debugging your test sequence. So you have an external trigger device. You can replace it through this manual switch just to initiate the execution of a test sequence. And later, of course, it will be executed by this external device. So this product is coming up, but alternatively, you are of course also free to establish your own generic solution. You see here 2 examples, 2 proposals of a circuit, how to interface to external devices. We have many more such examples documented in our FXControl help file. So you will find these ideas, these proposals, these circuits in this document, and you can select the one that applies for your test setup. Well, we are at the end of our presentation, and just a few words before I come to your questions. If you have any question, please contact us or any of our partners worldwide. They are very experienced, very skilled people over there who can assist you in finding a good solution. And if you want to watch this webinar once again, or another webinar or previous one, just visit our website that you see the link down there, and there you will hopefully find the corresponding information.